Welcome back, gentlemen. The purpose of this video is to finish up on inverse functions. We're actually going to determine whether a function has an inverse or not, and if it does, we're going to determine how to find that inverse. Okay, so let's get started. First, let's determine if a function has an inverse. That's first and foremost. And so we got three properties here we have to look at. One is f is 1 to 1, and not sure if you guys remember what 1 to 1 means, but 1 to 1 means that for each y value in the range, it corresponds to exactly one x value. Okay, so every y value is associated with only one x value. That's what it means to be 1 to 1. Okay, a function is f is strictly monotonic. Strictly monotonic means that the function is always either increasing or decreasing. All right, so if it's always increasing, it's going to be 1 to 1, and if it's 1 to 1, it's going to have an inverse. One of the easiest ways to look at a graph and to tell if it has an inverse is to see if it passes the horizontal line test. Horizontal line test will tell me whether or not a function is 1 to 1. And basically what it says, f is 1 to 1 and therefore has an inverse if every horizontal line intersects the graph of f at most once. Okay? So what do I mean by that? Let's take a look here. Let's look at this function right here, y is equal to x squared. And we actually saw this in the last video. And I told you that we restricted the domain. And the reason is, look at this. If I draw a horizontal line, or close to a horizontal line, we can see that that gets intersected at two spots. And it's intersected at two spots tells me it's not 1 to 1. Because this y value here, right there, and right there, it's not associated with only one x value, it's actually associated with two x values. So what we did in the last problem last time is we said, all right, let's start our domain and go this way. And then I'm only looking at this part of the graph. And if I'm only looking at this part of the graph, then it is 1 to 1. Okay, so that was the trick that we used before. So this function, as is, without restricting the domain, is not 1 to 1 and therefore doesn't have an inverse. Okay. Let me get rid of that stuff. Let's look at one that does have an inverse. Okay. And let's go there. Get my pen back. This is a cubic function. This one is always increasing. Okay, so that's one giveaway. Any horizontal line I draw here is only going to intersect it once. So this function does have an inverse. And remember, inverses reflect over the line y equals x. All right, let's go. How do I find an inverse? Okay, so once we determine whether a function has an inverse, how do I find it? Well, simply, I write the equation y equals f of x, like that. I switch the x and y values. If I switch the x and y values and then I solve for y, the result is going to be my inverse. Okay? And remember that we have to, the domain of the inverse function is equal to the range of the original function. And then the last step we want to do is verify. So again, we want to interchange x and y, solve for y. Once we do that, that's our inverse. All right, and then we have to state what our domain is. Let's do an example. Okay, here's a function right here. The problem already restricts the domain. We do that because we have a radical. We have to make sure we're always positive here. But we're restricting the domain as x is greater than or equal to 2. This tells me automatically that the range of f inverse, let me write that down, range of f inverse is y is greater than or equal to 2. Let's remember that. And let's look at the range of this. The range here of f of x. You should note if I start at 2, this is going to give me 0. So it's going to go 0, and they're just going to get bigger. We're going to go off to infinity. All right, let's just make notes of that so that when we see the graphs later on, we're familiar with it. There's the function, okay? And you should see that any horizontal line is only going to pass that once. You should also note that it's always increasing. Therefore, it's 1 to 1, and therefore we have an inverse. So we do have an inverse, so let's find it. I say y is equal to x squared root of x squared minus 4. Next step, they tell us to switch x and y. So if I switch x and y, that's what I have. Now it says, now we're supposed to solve for y. So first step, if I'm going to solve for y here, is to square both sides. that. Now I'll bring the 4 over and take the square root, and you should see that I get y is equal to the square root of x squared plus 4. What does that tell me? That tells me that that's my inverse. Okay, so again, interchange x and y, solve for y. Once we solve for y, that's our inverse. The domain of f is equal to the range of f inverse. The domain of f inverse is equal to the range of f. We already did that. It's right here. Okay. We want to check. We want to see, is this true? Does this work? So we go f inverse of f of x. I just plug in. If I square this term, you should see I'm going to get x squared minus 4 plus 4. And that's simply going to be equal to x. I can check it the other way, like that. Again, I'll get square root of x squared plus 4 minus 4. And again, that's going to equal x. If I take a look at what the graphs look like, here it is. Remember the domain here, the domain of this function was equal to 2 to infinity. And the range here was equal to 0 to infinity. This is the domain. This is the range. And if I come over here, we're going to see that the domain here is 0 to infinity. And the range here is going to be equal to 2 to infinity. So again, you can see that the domain became the range, and then the range became the domain. Again, make sure you guys understand this and this. Okay? Hopefully that makes sense. Here's some practice. Again, you already read the chapter. Pay particular examples to those. These problems are looking at do we have inverses? If we do have an inverse, find the inverse. Okay? So this is it for chapter 1. We have a couple more videos that have to do with quadratics for week 1. Email me with any questions. But a quick review is, 1, we learned how to determine whether a function had an inverse, and then we learned how to find that inverse if it did exist. Okay? Any questions, gentlemen? Make sure you email me. Okay? Have a good day.